Time is the ongoing sequence of existence and events that moves in one direction, from the past through the present and into the future. Time is crucial for sequencing events, comparing durations and measuring changes in our world. In physics, time is considered the fourth dimension alongside the three dimensions of space. The unit we use to measure time is the second. Time can stretch and compress, especially around massive objects like black holes. In our daily lives, time holds immense value. We've all heard the saying, time is money. Each day, each moment is unique and valuable. How did people know what time it was, or even what day or month it was? The answer lies in the sky. Ancient people were incredibly observant of the natural world, and they quickly realized that the sun and moon followed predictable patterns. The sun was the primary tool for tracking time during the day. As the sun rose in the east and set in the west, its position in the sky provided a natural clock. By observing the length and direction of shadows cast by objects, early humans could estimate the time of day. But what about longer periods, like months and years? This is where the moon came into play. The moon goes through a regular cycle of phases, from new moon to full moon and back again, approximately every 29.5 days. Early people used these lunar cycles to measure months. Let's talk about the science known as the arrow of time. Unlike space, where an object can travel in multiple directions and dimensions, time appears to have only one dimension and one direction. The past lies behind us, fixed and immutable, while the future lies ahead, uncertain and full of possibilities. But here's the twist. Most laws of physics allow processes to proceed both forward and backward in time. So why does time seem to only move in one direction for us? This phenomenon is known as the arrow of time. There are several acknowledged examples of the arrow of time. Let's start with the radiative arrow of time. This is observed in waves like light and sound, which only expand as they travel through time. Next, we have the entropic arrow of time. According to the second law of thermodynamics, isolated systems evolve toward greater disorder, or entropy, rather than spontaneously becoming more ordered. In quantum mechanics, measurement is irreversible. Once you observe a quantum system, you can't unsee it. The weak arrow of time comes from particle physics. It shows a preference for a certain direction of time in the behavior of subatomic particles, specifically through the violation of CP symmetry. Lastly, we have the cosmological arrow of time. As the universe continues to expand, it marks a clear direction from a highly ordered initial state to a future of increasing complexity and chaos. The relationship between time and space merging into what we call spacetime. In Einstein's theories of special relativity and general relativity, time doesn't exist in isolation. Instead, it intertwines with space to form a four-dimensional fabric known as spacetime. This means that our perception of time, as well as its measurement using instruments like clocks, can vary significantly for observers in relative motion. Despite these differences in perception, one crucial aspect remains unchanged, and that is causality. The past is defined as the set of events that can send light signals to an entity, while the future consists of events to which an entity can send light signals. Imagine, if you will, the ability to move backwards or forwards to different points in time, much like how we navigate through space. But what does time travel really entail? Unlike the normal flow of time experienced by an earthbound observer, time travel suggests that all points in time, including the future, persist in some way. This opens up a world of possibilities, but also a Pandora's box of theoretical problems and paradoxes. One of the central issues with traveling back in time is the violation of causality. If an effect precedes its cause, it could give rise to temporal paradoxes. If a time traveler were to go back and prevent their grandfather from meeting their grandmother, it would mean the time traveler could never have been born to make that trip in the first place. This creates a loop of contradictions that boggles the mind. One such theory involves the existence of branch points, parallel realities, or even alternate universes. In this view, changing the past creates a new timeline, leaving the original timeline intact. This concept is often explored in science fiction, where characters navigate through multiple realities, each with its own version of events. Another fascinating solution is the Novikov self-consistency principle, which suggests that any actions taken by a time traveler were always part of history. This means that free will in the past is an illusion. The time traveler cannot change events because those events have already happened in their timeline. Many ancient cultures, particularly in the East, viewed time as cyclical. In these traditions, time was often seen as a recurring pattern of ages or cycles where events and phenomena repeated themselves in a predictable manner. One of the most famous examples of this concept is found in Hindu philosophy, where time is depicted as a wheel called the Kala Chakra, or Wheel of Time. According to this belief, the universe undergoes endless cycles of creation, preservation, and destruction. Similarly, in other ancient cultures such as those of the Mayans, Aztecs, and Chinese, there were also beliefs in cyclical time, often associated with astronomical observations and calendars. These cultures developed complex systems to track time, seasons, and celestial movements. The cyclical view of time contrasts sharply with the linear concept of time more common in Western thought, where time is seen as progressing in a straight line from past to future without repetition. This linear perspective is particularly prominent in Abrahamic religions like Islam, Judaism, and Christianity. In these traditions, time begins with the act of creation by God and progresses towards a definitive end, often associated with eschatological events or the end times. Similarly, the Greek language distinguishes between chronos, representing chronological or sequential time, and kairos, which signifies the right or opportune moment, often seen as metaphysical or divine time. In Greek mythology, Kronos is personified as an old wise man with a long grey beard, often referred to as Father Time. Time, in this view, is a product of Maya influenced by our senses and imagination, and is seen as impermanent and subject to change and decay. Two major viewpoints dominate Western philosophy. The first, championed by Isaac Newton, suggests that time is a fundamental part of the universe, a dimension where events occur in sequence. This Newtonian time is absolute, existing independently of the events it measures. On the other hand, philosophers like Gottfried Leibniz and Immanuel Kant argue against this realist view. They propose that time is not a container for events, but part of a fundamental intellectual structure. According to this perspective, time, like space and number, is a framework within which humans sequence and compare events. In this view, time itself is not measurable, nor can it be traveled. It is a mental construct that helps us make sense of our experiences. Whether time has a subjective component is still a matter of debate. Is time felt as a sensation, or is it a judgment we make? The ancient Greeks, including philosophers like Plato and Aristotle, pondered similar questions. Plato viewed time as created by a divine being, while Aristotle saw it as correlated with movement and change. Fast forward to the 17th and 18th centuries, and we find philosophers questioning the very nature of time. Is it real and absolute, or simply an intellectual concept? Realists like Newton believed time to be a fundamental part of the universe, whereas anti-realists like René Descartes and John Locke argued that time is a construct of the human mind used to sequence events and understand our world. So is time real or unreal? Is it tenseless or tensed? Does it happen all at once, or is it a duration? In conclusion, the nature of time, from the movements of the sun and moon to the concept of time travel. Different cultures offer unique perspectives, viewing time as either cyclical or linear. Quantum mechanics, for instance, challenges our classical notions of time, suggesting that time may not be as straightforward as once thought. The concept of quantum entanglement hints at possibilities where time and space are intertwined in ways that defy conventional wisdom. Could AI one day help us solve the mysteries of time travel, or even predict the future with unprecedented accuracy? Scientists and technologists are working tirelessly to decode the algorithms of the universe, offering glimpses into a future where our mastery over time could reach new heights.